Now, for this recording, we'll only be focusing on question 1. So this question 1 is coming from November 2023, paper 1. In the description box, I'll leave links for other questions that I've answered for this November 2023 paper. So the question 1, it mostly focuses on module 1 topics, right? Your percentages, your BODMAS, your ratios, your, what's the last topic? Well, not the last topic, but one of the topics under module 1, your ascending and descending ordering of numbers. Did I mention percentages? Yes, I did. There's also rates as well under this question 1. So it covers pretty much everything that we have done in module 1. Now, here we have a total of, okay, the question 1 starts from 1.1 all the way up to 1.7. So on screen I have 1.1 to 1.4. We also have questions from 1.6 to 1.5 to 1.6, and the last question 1.7. So we're gonna answer all questions under this question 1. So for the 1.1 question, it deals with BODMAS. So they want us to calculate the following. Show all your calculations, right? Do not use a calculator for this one, right? Because think about it. It's a 2 by 2, which is a total of 4 marks, meaning that each question is allocated 2 marks. So there's 1 mark for the method or the simplification of your sum, and then there's also another mark for the final answer. So make sure that you show all your calculations. So in this instance, we are given a sum to simplify through BODMAS. So BODMAS, we always start with the bracket. Now, for the first one, 1.1.1, that is 80 plus 20 divided by 5, right? We don't have a bracket, so I'm gonna skip that. We don't have an order or off. I'm gonna skip that, but we do have a divide, right? So between the plus and the division sign, which operation do we have to start with? We're gonna have to start with the division part, right? So we start off by dividing before adding. So what is 20 divided by 5? That is 4. So I'm gonna have a 80 plus a 4. You start off by dividing and then you get a 4. So what is 80 plus 4? That's 84. This is what I was talking about, that there's 1 mark for the simplification of the method that you have used for simplifying, which by the way is the BODMAS, and another mark for the final answer. So make sure that you show your calculations. In 1.1.2, we now have a second sum, 9 plus 6 minus 5 plus 5 squared equal to. All right, again we consult BODMAS. Now BODMAS says what? You always start with the brackets. We actually have 2 brackets, so we need to solve them simultaneously, right? So I have bracket here and another bracket here, so we need to put more priority on the brackets, right, over everything else. So I'm gonna start with the first bracket. So I'm gonna solve what's inside the bracket. So a 9 plus a 6 adds up to what? To a 15. Yeah, 15. And then here I have a negative 5 inside a bracket, right? So in other words, we'll have to simplify for the bracket by multiplying with the negative sign inside that bracket. So the negative and this negative multiplying gives us a plus 5, a plus, and then we also have a order. So I'm done with the brackets. I will have to solve for the O now. So anything that has to do with roots and exponents, that is what we call of or order. So what is 5 squared? That's 25. Now, so I have the same operation, so it doesn't matter whether you add here first or you add here first, but I think it makes sense just to add everything up because it's just one operation. So 15 plus 5, that is 20, plus a 25, that gives us a 45 as our final answer. So here it's 1 mark for the method and 1 mark for the final answer. Now 1.2, there are 28 learners in a class. The number of boys in the class is 16. Half of the class are hockey players. All right. We are told that, okay, in a classroom, we are given a total of 28 learners. We are also told that the boys in the class are 16 and half of the class are hockey players, right? So the first question, they want us to calculate the percentage of boys in the class, and then we have to round off our answer to the nearest percentage. Now, how many boys do we have? We want to calculate the percentage of boys equal to, how many boys do we have? According to the question, we have 16 boys divided by 28 multiplied by 100. So how do we calculate the percentage? A percentage is calculated as number divided by the total number. So it's the sample divided by the total sample, right? The total of the sample multiplied by 100. So how many boys do I have? 16 in total. So I have 16 boys compared to how many? Compared to a population of how many, or how much? It's 28, right? So the 16 is coming from the 28. So the sample of boys is coming from a population of 28 multiplied by 100. So think of a percentage like that, right? So what is 16 over 28? Let me grab a calculator for this. 16 over 28 multiplied by 100. I'm getting a 57,14 in 2 decimal places. This is not the final answer. However, this is not the final answer. Remember, in the question, they want us to round off our answer to the nearest percentage. They want us to round off to the nearest percentage. So it means that the percentage should be rounded off to a whole number in a way. So we're going to take the 1 and round off the 57. So this becomes the final answer. So 1, it doesn't round up, so it stays at as 57%, right? So this is what they mean by round off to the nearest percentage. Leave it as a whole number. 1.2.2, how many of the learners in the class play hockey? They say half of the class are hockey players. Out of the total of 28 learners, half of the class plays hockey. Now, the question is, how many of these learners are playing hockey in the classroom? So, hockey players, the number of hockey players is actually equal to 28. So that's the total of learners in class divided by 2. That's how we get a half of anything, right? So 28 over 2, that gives us 14 learners, which is like 50% of the classroom, right? Okay, next question, 1.3. Arrange the following numbers in ascending order. So in other words, we'll have to arrange them from small to the biggest number, right? So again, the issue of writing numbers in ascending or descending order. Think of a number line, man. minus 1, minus 2, minus 3, 1, 2, 3, then 4. So when trying to write down numbers in ascending or descending order, in other cases you might be given, say, maybe even percentages, fractions, whole numbers, negative numbers, all in the same problem, right? So try by all means to sort of like simplify the numbers. What do I mean by that? Let's say maybe we had a percentage here. Maybe they said there's also a 50%. Try to change this 50% into a decimal. Also a fraction as well. Try to convert it to a decimal. So in this instant, what I would do, okay, there's no 50%. Let me remove that. So the half, I would actually convert to a decimal. What is a half in decimal form? So by punching this on the calculator, you're going to get something like a 0.5. Okay, so now this somewhat makes a little bit of sense. So going back to the number line, so when arranging numbers in ascending order, you need to start with the negative numbers and go all the way up. So on the number line, your numbers are ascending from left to right. This is the scale of ascending. Then from right to left, descending. You are arranging them from high to low, or small, or big to small. And then ascending, you are arranging from small to big, or low to high. So that's ascending, right? Ascending. Now, between a negative 2, a 0.5, and a 0.4 and a 0.5, which one is the smallest out of the three? I think it's obvious that the minus 2 is the smallest value. So we're going to start with the minus 2. And then the next value that is the smallest, between a 0.5 and a 0.4, which one is the smallest? It's obviously the 0.4. 0.4 is actually smaller than a 0.5. So next one would be the half, the last one. So the half is actually the biggest number out of the three. So this is how I would arrange the numbers in ascending order. Negative is the smallest, so it's to the left of the 0. 0.4 is just closer to the 0, and then the half, which is also a 0.5 in decimal form, which is bigger than the 0.4, so that's gonna be the biggest value out of the three. Hence, I'm putting it last. Now, 1.4, we see Pindi picking 800 oranges. She filled each bag with 26 oranges. How many bags did she fill? All right, so in this scenario, we have a total of 800 oranges. We need to put them in bags of 26 oranges. So it means that each bag will contain 26 oranges. Now, we want to calculate the number of bags that will be filled with oranges. Né? So to do that, this is sort of like a grouping problem in a way. So out of the 800 oranges, I need to make groups of 26 and put them in a bag. Another group of 26, put it in a bag. Another group of 26, put it in a bag, until all the oranges are put in a bag. Now, just pay attention to this question. How many bags will she fill? I think this word was supposed to be put in bold to say it's crucial or important that the bag is filled with 26 oranges. If the bag contains 25 oranges, it's not filled, right? If it contains 23, it's still not filled. It needs to have 26 oranges in total to be filled. Okay, so this is a grouping problem. So grouping involves division. So we're going to take the 800 and divide it by the 26 group of oranges. So what is 800 divided by 26? I'm getting 30,76 bags. But this shouldn't be the final answer, right? Remember, the bags, we don't have half a bag. We need to have a full bag. Why? Because the bag needs to be filled with 26 oranges, not less, not more, strictly 26. Now, actually, there's gonna be 30 bags. The final answer should be 30 bags. 30 bags will be filled. The 0.7 is saying that there's actually like a bag that exists, but it's not filled. It's not filled with 26 oranges. Let me show you something. Take the 30 and multiply by 26. 30 multiplied by 26. Multiplied by 26, I'm getting 780 oranges that are filled. So we have a total of 30 bags that are filled with 26 oranges. So in the 30 bags, we only used or packaged 780 oranges out of the 800. Now taking the difference between the 800 and the 780, I'm getting 20. So it means that the last bag has 20 oranges, but a full bag should have 26, right? So we actually have a total of 31 bags, but the last bag is not filled with 26 oranges, right? It's not filled with 26 oranges. Hence I'm saying the fill was supposed to be maybe bolded or something, just to put emphasis on the fill. How many bags did she fill with 26 oranges? The answer is 30 bags. 30 bags. The last bag doesn't have 26 oranges. It only has 20. All right, moving to the next question. We have 1.5. A train travels. Okay. The train leaves the station at 18:15 a.m. It arrives at its destination at 20:30. Right, at 20:30. 1.5.1. 1.5.1. They want us to convert this 20:30 from a 24-hour clock to an analog clock, AM, PM. So this is something that you should know. We did time conversions in class, yeah? Module 1, time conversions between the analog and the digital clock, right? So the 24-hour clock is the digital one. The analog, the AM, it uses the AM, PM system. Now, 20:30, that's actually in the evening. So it's gonna be PM. So the answer here, 20:30 to an analog time, it's gonna be 8. It's gonna be 8:30 p.m. 8:30 p.m. So this is the answer for 1.5.1. 1.5.2, calculate the duration of the train trip. So when doing calculations with time, just make sure that you work with the 24-hour clock. So with this one, the train departed what time, or left the station at what time? It left the station at 8:15 p.m. So it's always the final time minus the starting time. So how do we do that? So what's the final time, the arrival time? It's actually 20:30. Remember what I said initially is that you need to do calculations in 24-hour time. Alright, so it's gonna be the 20:30, which is the final time, minus the starting time, which is 8:15. So changing the 8:15 a.m., which is in the analog time, to the 24-hour time, it's actually 8:15. So it's gonna be the same. Now taking the difference between the two values, this is a time-lapse question. Taking the difference, what is 20 minus 8? That's 12. 30 minus 15, that's also 15. So this is the duration of the trip, 12 hours and 15 minutes. This is the answer. Convert your answer in 1.5.2 to an answer in seconds. Interesting. Okay, so 1.5.3, we actually have to convert this answer, 12 hours and 15 minutes, to seconds. Now we'll start with the 12 hours. How do we convert hours to seconds? We multiply by 60, then we change it to minutes. Multiply by another 60, then we change it to seconds. Alright, so there's one. Okay, me multiplying by 60, I'm changing the hours to minutes. Multiplying by another 60, I'm changing the minutes to seconds. Yeah, let me put it that way. Let me just put it that way. So 12 times 60 times 60, I'm getting 43,200 seconds. 200 seconds. Now let's change the 15 minutes. So from minutes to seconds, I'm just going to multiply by 60. So 15 times 60, I'm getting 900 seconds. Now we're going to add the two values, the 43,200 plus 900. I'm getting 4,100 seconds. This is my final answer. Okay, 1.6. We're almost done. Okay, now a concentrate and water mixed together in order to make juice. The ratio of a concentrate to water is 1:5. What is a concentrate? A concentrate is it's just juice, undiluted juice, right? Like Wild Island, Oros, stuff like that. So 1.6, 1.6.1. Now, when you make juice with a concentrate, you don't just take the juice and drink it. You need to dilute it with water, right? So on 1.6.1, they want us to calculate how much water will be needed for 3 liters of concentrate if we are given a ratio of 1:5. Now, the ratio of a concentrate to water, perhaps let me underline this. The ratio of a concentrate to water, it's 1:5. So that means a concentrate to water ratio is 1:5. So it means that for every 1 part of a concentrate, you're gonna need 5 parts of water. If you have 1 liter of the concentrate, if you want to use the whole concentrate, you're gonna need 5 liters of water, right? Now calculate how much water will be needed for 3 liters of the concentrate. So I'm given 3 liters of the concentrate. How much water is required? I'm going to place an x, then cross multiply. X times 1, that's x. 3 times 5, that's going to be 15. So x amount of water, it's going to be 15 liters. That's the answer here. Now for 1.6.2, determine the quantity of juice in liters if 3 liters of concentrate was mixed with the correct amount of water. So this 1.6.2 ties up to the previous question. Now the question, just to give context or clarify the question, they are saying that if the 3 liters of concentrate was mixed with the right amount of water, how much in total would you have? How much quantity of juice would you have? Actually, the answer would be to say the 3 liter of the concentrate. The 3 liters of the concentrate plus the 15 liters of the water, right? So when everything is mixed up together, right, it's the concentrate with the right amount of water. When mixed up, it's gonna give us 18, am I right? Yeah, 18 liters of juice. So this is how much you're gonna drink. This is how much you're gonna drink. Now for the last question. Where's that coming from? Oh yeah, here we are. Okay, 1.7, a car travels 387 kilometers in 3 hours. Speed riding. Okay, the speed limit on the road is 120 kilometers per hour. Did the driver of the car break the law? Now, this is the speed limit, 120 kilometers per hour. They are asking us if, as the driver was traveling this distance over this period, was he breaking the law or obeying the law or within the bounds of the law? Did the driver of the car break the law? Give a reason for your answer. You may use the formula speed is equal to distance over time. So what the question requires of us is that we'll have to calculate the speed at which the car was traveling over that duration, over that distance. So for 1.7, we need to do the following. 1.7, we need to calculate the speed is equal to distance over time. What is the distance traveled? It's 387 kilometers over time. That is 3 hours. So let's get the speed. 387 divided by 3 hours. The answer is 129 kilometers per hour. Now let's compare with the speed limit. So as you can see that the car was traveling beyond the speed limit. So I would say, therefore, did the driver of the car break the law? Yes. Traveling above speed limit. The driver was traveling above speed limit. So yes, he broke the law, or she broke the law. All right, I'm saying he because men are reckless drivers for sure. All right, now check the description box for more recordings that I've done for this question paper. So for now, I'm signing out, guys. I hope you enjoy this recording. We like it, we share it. Leave a question in the comment section if you have any questions. I'll see you on the next one. Bye bye.